Now, there's an easy way to determine if something is one-to-one when you look at the graph. In order for a function to be one-to-one, it must pass the horizontal line test. I got two functions. One's red, one's blue. Do they both pass the vertical line test? Yes, if they pass the vertical line test, that means that they are functions. Okay? Now, do they both pass the horizontal line test? No. Which one fails it? The parabola, the blue one, right? So if the blue one fails it, then it's a function, but it's not one-to-one. The red one passes both, so it's a one-to-one function. Do you see the difference? Awesome. Now that we've established what one-to-one to is, then we can talk about inverses of functions, which is truly our goal for the day. If a function is one-to-one, we say it can have an inverse. Now you're thinking to yourself, what the heck is an inverse, Mr. Gens? I've got great concrete ways to show you exactly what an inverse is. -3 plus something is equal to 0. What is that something? 3. We say that these are inverses under the operation of addition because they produce 0. Kind of like 5 has an inverse under addition. What's the inverse of 5 under addition? -5 because it produces 0. So addition will produce 0 for the inverse, okay? 2/5 times what is 1? 5/2. So these are inverses under the property of multiplication because they produce 1. So every operation has a different thing that it produces to show an inverse, okay? So the question is, all right, what about functions? Say I have f of x is equal to 2x minus 1. What is the inverse? Why do we even need to know the inverse? Turns out that inverse of functions is extremely important, especially as we move into chapter 4, 5, and 6, and 7. You're going to use them all the time. And I'm just trying to make it as plain as possible. You can see how you're used to dealing with numbers when you're thinking of functions just a little bit different, right? But yesterday when we started composition, was composition new to you? Yeah, you didn't know composition before yesterday. Do you know composition now? Yeah, it really wasn't that bad. It's the same deal with today. Today, coming here, be like, function inverses? What the heck? After you leave today, be like, oh yeah, I know how to do that. We'll show you exactly what it is. Function inverses, you take a function's domain and it becomes the range. You take a function's range and it becomes the domain. Or basically, you take the x values and they become the y values. You take the y values and they become the x values. So watch how this works. I'm going to give you one of the most basic functions in the world. Cully, give me a number. 4. Asher, give me a number. 5. Love it. That's a function, isn't it? It's a really basic function. It's only got one thing. You plug in 4, you get 5. It's pretty boring. But it's still a function, and it's one-to-one. If I ask you what f of 4 is, what would you tell me? If I plug in 4, what do I get out? 5. Well, here's what that looks like for inverses. If I do f inverse of 5, that means with an what? There we go. Sorry, YouTube. Yeah, we're good. There we go. That's for you, and this is for you. It's your friend. There you go, friend. There you go. Okay. So this says an input of 4 produces an output of 5. This is saying that an output of 5 is produced from an input of 4. This x value gives you this y value. This is saying if this is the y value, what would be the corresponding x value? You see the difference? Okay. Now, what if I switched it? What if I said f of 5? Is there anything that tells you if you plug in 5 what you get? No, you would have to have another point, right? So I'll make one. We'll just say 5 and pick a number. 7. So that would mean that f of 5 is 7. So you tell me what the f inverse statement is then. F inverse of 7 is 5. What if I asked you what f of 7 was? Could you tell me what f of 7 was? No, we don't have an x value of 7, okay? Let's see how these are all related. Good, good work. What does that look like graphically? They're reflected over the line y equals x, and we're going to check that out in just a little bit. It's super cool when you see it. But let's look at examples 1 and 2, and then we're going to let you do some of your homework. You guys said you like that when I have you do some homework in class, right? So we'll try to do it as many times as possible. It's not going to work every day, but we'll try to fit it in when we can. This says that given f of 2 is 3, f of 1 is 9, f of negative 3 is 8, and f of 4 is 5, and f is a one-to-one function, find the following. F inverse of 8. That means I have an output of 8. What would be the input that would give you 8? Yeah, negative 3. F inverse of 3, 2. F inverse of 5, 4. And F inverse of 9, 1. Now, I always think it's easy to come back to a coordinate. For example, like this one right here is the coordinate negative 3, 8. And from there, I can think of two statements. F of negative 3 is 8, and F inverse of 8 is negative 3. So bring it back to the coordinate is always the way to do it, okay? And I say that after, it comes up again in AP Calculus. I always have the kids produce the coordinate. And here's a classic example. We're just going to switch it around a little bit, but all of a sudden it gets confusing. It says, given f of x is 3x minus 8, find f inverse of 6. Shoot. Is 6 the x value or the y value? The y value. Very good, Dane. So we have an x value and a y value of 6. So I'm saying if there's a y value of 6, what's the x value? How would I determine that? 6 in for the f of x. So 6 is my y value, my f of x value, and that equals 3x minus 8. So what would x be? 14/3? Yeah. Not too bad, right? Okay, I'm going to hand out your assignment. You're going to start on the first two questions. They actually only take you about a minute and a half. Doyle. Okay, all right, good work, folks. Now I'm going to show you how to actually find an inverse, okay? So you found the inverse of coordinates, but what about functions? And that may sound super challenging. We're going to make it really easy, and it's going to be easy because you guys are really intelligent. Think of how difficult this class would be if you weren't really intelligent. I mean, this would be almost impossible. So suppose f of x is 2x minus 1. You want to find f inverse. That's what we want to do. Like, what is literally the inverse function? And it's super easy. The secret is right here. X becomes y, and y becomes x. So what I do is I take this y equals 2x minus 5, and I switch the x and the y value. I go x equals 2y minus 5. Hey, that's super cool. Now I just solve for y, and it will produce for me the inverse function. What's that? I don't even know what she's saying. Like, how do you respond? You most definitely did not do this. Sure. So like logarithms, maybe. So did you do like this? E to the x, or natural log of x? Okay. Yeah, I think you're. I think you maybe had a dream or something. You're confusing life. So okay. So here's what I want to show you. All right. So I came up with the inverse function. That's all it is. Okay. Now watch this, folks. I'm going to type in my calculator. I'm going to type these three functions. I've got y is 2x minus 5, and then I've got my inverse, which is x plus 5 divided by 2. And I told you that graphically they'll be reflected over the line y equals x. So I also have y equals x. So watch this graph as it pops up here. It's really cool. Here's y equals x, and then there's the first one, and then you can see it flips over to produce that one. See how they're inverses? Watch. This has a y-intercept of -5. That means its inverse will have an x-intercept of -5. This has an x-intercept of 2.5. That means its inverse will have a y-intercept of 2.5. You see, if you were to just flip this thing over that middle line, you would produce the other, right? And that's the way it goes with all inverse functions. It's pretty cool. Look at the next one. This is more complicated, isn't it? We get y equals 2 minus x over 3x minus 4. What we're going to do is switch those x and y values so that we have x over 1 is equal to 2 minus y over 3y minus 4. Oh, no. We need to solve for y. Unfortunately, there are two y's. What do we even do? Dano is saying that we cross multiply. Good idea. X times 3y is 3xy. X times -4 is -4x. And 2 minus y times 1 is 2 minus y. Awesome. I've taught you this before because, believe it or not, I try to intentionally think about the skills that you need to be successful down the road. Does anybody know what I do here if I want to solve for y? Get all the y's on one side. Now, when I taught you this before, we were solving for x, so we gathered the x's on the same side. But right now, we're solving not for x, but for y. So we put all the y's on one side. So I've got a 3xy plus y equals 2 plus 4x. So I brought the y's over. Anything that doesn't have a y goes to the other side. Now, this is the key. What do? Factor out the y. And when I factor out the y, I'm left with 3x plus 1. And that's equal to 2 plus 4x. Now what? Divide. Y is equal to 2 plus 4x divided by 3x plus 1. And that's its inverse. Pretty cool, huh? I want you to take your worksheet and don't look at 3. You're not ready to do 3. You're going to flip to 4. Flip to 4. And right now you could be working on A, B, C, D, and E. Okay? Take about 3-4 minutes. And then we're going to move to our last section. It looks like I got the schedule here for today. We got this odd day here. We got the assembly. We're at 12:15. Yeah, so if you give me 10 minutes, we should be able to finish off that last section. So take a few minutes to work through this piece. Call people out. Okay. Second of all, here's what else you got. Okay, on your study guide, I have an extra practice sheet on your study guide. You are not required to do that to get your extra point. But suppose Josie is going home and doing her study guide, and she gets through it. She's like, I wonder how I'd actually do on the test. Then do that extra practice. It's just a front and a back, and it'll be a really good indication of how you're going to do on this test. Okay? Again, I think you guys are in good shape, but this is the #1 retake test of first semester. Okay? All right? So this is one you want to buckle down and get ready for. All right. Flip your notes over. I got y is equal to 2 minus 3x cubed, and I'm going to switch that to x equals 2 minus 3y cubed. What do? Add the 3y over. So 3y cubed is equal to 2 minus x. So I subtracted the x over, and I moved the 3y cubed over. Now what? Do I divide by 3 or do I cube root? Which one first? Divide the 3 off. Y cubed is equal to 2 minus x over 3. Now, cube root. Y is equal to the cubed root of 2 minus x over 3. No big deal. Looks crazy, but that is the inverse. Now we got a really interesting one. This is I think the most important problem today. It helps bring all the learning together. And I really think it's going to help you out, okay? So I'm going to take this, and first I'm going to create the graph, because I could have done it for this one as well, but I'm not going to for the sake of time. But I'm going to produce the graph, and I just want to make sure that one looks like the inverse of the other, okay? So what does that graph look like? It's a square root function. What does a square root function look like? Yep, everybody does that. It's like same every year. Everybody does that thing. Yep. And then to the left one, well, good, awesome. All right, people have retained their learning from last unit. Awesome. You should be able to take any function after this class and be able to graph it. So there you got 4 plus the root of x plus 1. That's what it looks like. It's always easier when you can see it, right? All right, so we know it's at the point -1, +4. Well, if what we've learned about inverse is true, then this next one, instead of starting at -1, 4, it should start at 4, -1, right? Because the x and y values switch. Let's see if that happens. I've got x equals 4 plus the root of y plus 1. What do? Got to solve for y. How? X minus 4 equals the root of y plus 1. Square both sides. X minus 4 squared is equal to y plus 1. X minus 4 squared minus 1 is equal to y. What shape does that make? It's a parabola, and it's shifted to the right 4 or left 4? Right 4, up 1 or down 1? So just like we thought, it sits over 4 and down 1. Isn't that cool? But wait a minute. I mean, that looks like the inverse, right? But the parabola also produces that as well, doesn't it? I mean, if you were to reflect this radical over the line y equals x, you wouldn't be getting that whole thing. You'd just be getting part of it, wouldn't you? What happened in our process that we came up with an extra piece? We squared it, and when you square something, all of a sudden you add stuff you didn't want to. So what we need to do is we need to get rid of that section. I know you're thinking to yourself, well, how do we get rid of something that all of a sudden just popped up? It's not that bad. I'll show you. What is the domain of the radical function? The radical function. What x values do I start to pick up with the radical function? -1 to infinity. How about the range? Close. 4 to infinity. What we said is that when you do inverses, they switch, don't they? So that means that the domain becomes the range, and the range becomes the domain. So the domain, we want it to be from 4 to infinity. Well, that's just the red part, right? So there you have it. That's our inverse. It's that quadratic with that domain. You had to restrict the domain because look at what you produced. Here's a hint you have a problem. Look at what I produced. I produced this parabola. Is that parabola 1-to-1? Does it pass the horizontal line test? No. If you produce something that's not 1-to-1, then you gotta cut it off. Simple as that. Okay, last piece. Flip it back 1 page. We got one more thing to do. Three plus -3 is what? That makes them inverses. 2/5 times 5/2 is 1. That makes them inverses. How do we test to see if functions are inverses? We use function composition. When did you learn about function composition? Yesterday. And just like addition produces 0 and multiplication produces 1, function composition has to produce something, and it produces x. But function composition is not commutative, so we have to check both f inverse. We have to check both f of f inverse and then f inverse of f. We've got to check it twice, and each time we should come out with x. And if you do that, then you will show that they are in fact inverses of one another. So that's the piece. We're going to do A and B, and we are done with our Unit 2. We'll be moving on to Chapter 3 next week. Bring it on. Bring on the snow. Bring on the turkey. Yeah! Property of inverses. Use property of inverses to determine if they are inverses of each other. How do we determine if something is inverses? Don't just switch x and y. Use composition. F of g of x. Compose them. What do I do? What does that mean? Yeah, grab that and plug it in for x. So I like to use parentheses around g. So I go 3 times parentheses x plus 5 over 3 minus 5. That way I make sure that I've kind of isolated it, and I can see what works out. What's going to happen when I multiply this by 3? What happens to the 3's? I cancel. Times 3 divided by 3. So I get x plus 5 minus 5. What's x plus 5 minus 5? X. Hey. We're supposed to come up with x. You got to compose it the other way, though, and make sure it works out as well. G of f of x. What do I do then? Take f and put it there for g. So parentheses, 3x minus 5, then what? Plus 5, then what? Divide by 3. Well, 3x minus 5 plus 5 gives me 3x. Divide that by 3, and I get x. Hey! I like that. One more. F of g of x. I take this g of x and I throw it there. And I like to use parentheses around that. That way I kind of keep my work organized. 1 over parentheses, 1 over x, we're almost done, minus 2, plus 2. The 2's cancel, and you get 1 over x. When you multiply by the reciprocal, you get x. Now, we're out of time, but you would also have to do g of f of x, and you would get the same exact thing. Compose functions to show that they're inverses. You guys have all of your stuff. Some of you are entirely caught up with your homework. Some of you guys got work to do this weekend. We will see you on Monday. Be safe drivers. Make great decisions. Be leaders. Go Gophers.